Hey class, in this video we will be determining whether a statement is a tautology. Okay, so what is a tautology? It is a compound statement that is always true for all possible truth values of that compound statement. Okay, so when you make a truth table, the end result is always true. That is what we call a tautology. Now, the opposite of a tautology is a statement that is always false, and that is called a self-contradiction. Okay, so that's the next video. This one will focus on whether it is a tautology. Okay, so here, given the statement, I'm going to say, determine if this statement is a tautology. And we want to determine whether P or Q and not Q implies P. Is that statement a tautology? Okay, so now what we're going to have to do is to build a truth table for that. And the question is it always true at the end? Okay, so in building a truth table, we first need to go and look and see how many simple statements there are. In this case, there are only two simple statements. That is P and Q. Those are two simple statements. Now, when you have only two simple statements, you have four possibilities in terms of truth values because each one of them have two choices, either true or false, right? So we would say here are our four choices: true, 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 false, false, true, and false, false. Those are your four choices. Now, what are we going to list next on our table? Well, it would be, we have to ask ourselves, what is our order of connectives, right? What is our order of connectives? The order of connective would be, first, we have parentheses. Second, we have negation. Third, we'll have and, or. Fourth is if then, and then fifth order would be if and only if. That is the order of your connectives, okay? So when we look here, the first order, we would go inside parentheses first. So this would be my first order. And then when you go outside, it's gonna be and or not Q. So not Q would go before and, so that would be my second order. And then my third order would be and then lastly, my fourth order would be if then. Okay, so how do I list them? In that order. Okay, so first I would go P or Q. And then next, I would say not Q would be my next order. And then I would say P or Q and not Q. With this being my main operation there, or connectives there. Okay, and then lastly, I would have P or Q and not Q implies P, with this arrow being my main connector. All right, so let's go and fill in the choices here. Okay, so P, I'm going to go ahead and actually label my columns so I can reference them. 1, 2, 3, 4, 5, and then 6. Okay, so first I am looking at column 1 and column 2, and the connective being or. Okay, so or means as long as I have one true value, then the result would be true. That's what an or statement is. Or means this, that, or both would work. So true and true, that would be the both case, so that would be true. True and false, as long as I have one, it's true. True or false or true, that would be true. And then when both false, then my result would be false, because and means I must have at least one true value in order for the statement to be true. Okay, not Q. Not Q means the opposite of whatever the Q value is. So Q is true, so not Q is false. Q is false, so not Q is true. Q is true here in this line, so not Q is false. And then the last choice would be Q is false, so this not Q would be true. Okay, next we are combining column number 3 and column number 4 with the connective and. And means both have to be true in order for your statement and statement to be true. So true and false will result in a false statement. True and true, when they are both true, the and statement is true. True and false, only one of them, so the and statement is false. And then false and true will result in a false statement, because I need both to be true in order for the and statement to be true. Okay. Lastly, I'm looking at the column number 5, arrow to number 4, to number 1, all the way to 1. Okay, so I'm looking at number 5, column 5, arrow, column 1, because that's what P is. So how does if-then rule work for truth table? If you see the hypothesis did not happen, it really doesn't matter what the result is. Your conditional statement will be true. Okay, because in order to really determine your hypothesis must happen first. So here the hypothesis happened. So you then look across and say, oh, look, the conclusion happened. So my conditional statement is true. Here, the hypothesis, meaning the first part of the arrow, didn't happen. So it really doesn't matter what the result is. My conditional statement still will hold its truth value. Same for the fourth choice. If you start with false, it really doesn't matter what the other side is. My conditional statement still holds its truth value. Therefore, this statement is always true. And when it is always true, we call that statement a tautology. A statement that is always true. The opposite of a tautology is a self-contradiction, which is what we will go over in the next video.